Greetings students, once again we meet to continue our discussion on electroplating, and I was discussing about the plating on aluminum. I had said that aluminum plating is slightly different from conventional electroplating because of the unique nature and reactivity of aluminum. Normally we try to prevent the natural surface oxidation. So, it is necessary to apply an immersion coating of zinc temporarily to prevent the oxidation. This coating is removed for the actual electroplating. The zinc electroplating is only a sort of precaution for aluminum plating. I had shown you this slide also, that is preparation of the basic material, and what we write here? We write that electroplating involves more than just a formation of for a solution. So, before a metal or non-metal can be electroplated, the surface must be physically and chemically clean. This we have to ensure. Physical cleanliness means freedom from oils, mud, greases, superficial dirts associated with packing material, plastics, and so many other things that are involved in that. And atmospheric dust also quite often is associated with the metals which are stored for long time in the open. That is also to be removed before we go for electroplating. So, we also use quite often chemical cleanliness. In the chemical cleanliness means freedom from oxides or other surface formed compounds. Quite often it is the oxides, sometimes it is, if it is copper metal, then copper sulphate, copper sulphide, silver sulphide, many other compounds associated with the atmospheric components that react with the metal. Usually it is sulphur and oxygen. Mechanical cleanliness, again it means freedom from the surface skin of the damaged metal. So, sometimes loose fragments are there, and when you there will be scratches, there will be stains, etc. These are produced by mechanical operations while removing one metal from another one from the other, from the bottom you want to take out one metal from another metal. So, there will be automatically some scratches and other things happening on the metal this thing. So, electroplating basically involves a series of operations, each of which is vital in its own way for determining the quality of the final product. So, what are the basic steps that are involved in electroplating? First of all, we have to remove the scales, and these scales are of oxides if it is stainless steel. Otherwise, many oxides and sulphides, as I had already explained to you. Sometimes the face of the metal gets tarnished. The metal does not have the shine that a metal should have. I think you have all experienced such kind of tarnish. Normally, when you go to buy a metal vessel or something in the shop, we expect the metal to be shiny and nice looking, etc. But if the metal in the same shop, if the vessel is kept for long time, there will be dust, and there will be, when you see that, you will say that, oh, this is old, this is tarnished, it does not have a shine, I will not buy it then. So, quite often what happens is the metal should, if it is very pure, it must have that special shine of a metal, and if it is not there, we will have to clean it. And mechanical preparation of the surface is one of the way to do that. So, you have to take a cotton cloth and buff it, wipe it nicely number of times, etc. Shopkeepers normally do that. Almost all metal articles they want to sell, every day morning they come and clean it with a clean it mechanically
with a cloth, so that the tarnish is retained. So, cleaning for physical cleanliness is a must. Then after cleaning, we want the metal to be the dirt and other things should be washed away, that is known as rinsing. What we do is we take the metal, dip it in water and take it out. So, that water will pick up the dirt, dust and fibers, this, that, etc. And then we go for acid dipping for chemical cleanliness. After you take out from the water bath, we just pull it out and then take it to another bath which contains acid. So, metal should to be dipped in acid. Which metal? It is the object which is to be electroplated. So, after that there will be certain amount of acid remaining on the metal. So, that acid residue will start acting on the metal. So, again that has to be removed. So, again I have a water bath in which I will dip the material, acid also will go down along with water, and then I have another one or two rinsing operations where the last remnants of the acids are removed before it is ready for electroplating. And after electroplating, again I have to go for rinsing and then drying. There is a error here, it is rinsing only. This is not there, it is rinsing. So, after electroplating, again I want to get rid of the chemicals that are adhering to the metal which is not electroplated. So, those things again need to be removed, and what is the best way to remove such chemicals is again take it for a rinsing and then one more rinse and then see that everything gets diluted and the electroplated material comes out soft, shiny, beautiful, etc. After that there is a requirement for drying, because water, even if it is left on a metal, can leave a small trace of stain. So, immediately it should be dried and then removed. It will be checked for quality and then only there will be other operations going on. So, basically this is the operation for all electroplating units. The chemicals may be different, mechanical preparation of the surface may be different, and acid dipping may be there, may not be there. Sometimes we clean it with alkali also, and that is also there, but again in general this is the sequence for base metals, that is involving iron, cobalt, nickel, etc. So, sometimes there will be heavy scale of oxides from hot rolling, casting and heat treatment, and also the removal of the rust and tarnish due to exposure to atmosphere. Here I have to explain to you that the metal which we normally take for electroplating, if it is kept for long time, it will pick up this exposure. There will be rust and tarnish will be there, and that is only due to atmosphere. But quite often the metal sheet or metal object that is to be electroplated itself needs to undergo several operations before it is ready for electroplating. Sometimes we hot roll it, it is called hot rolling. Sometimes we cast it. So, while casting it comes into contact with several chemicals, and then again those things need to be removed. Sometimes we give heat treatment, because heat treatment is one of the requirement for making the metal surface very tough. So, heat treatment is normally done in cyanide baths. So, there will be a coating of the nitride element, and that makes the metal harder, it will not break. It is like a tool, a tip of the tool that is usually heat treated, and there will be other, of course, removal of rust and etc. So, apart from the normal
tarnish, there will be exposure to several hot rolling, cold rolling, casting, heat treatment, and there are many other operations. A metal, before a metal is used for electroplating. So, this operation usually precedes polishing and buffing. It should be precedes again here. Let me correct it right now. Otherwise, I will make the correction here itself. Okay, it precedes. So, the mechanical operation usually after removing the scales etc., we need to do polishing and then buffing and pickling consists of immersing the article in a dilute HCl or sulfuric acid. Okay. So, mechanical preparation involves the polishing only, polishing, buffing and coloring sometimes, or it is known as electro polishing. The rough surface of freshly prepared articles are rendered smooth by mechanical operation. What do we achieve? Sometimes, quite often there is always a question, why should we clean it so much with mechanically also? Because when the metal is cast, the surface will be usually rough. It depends upon how you cast. If it is investment casting using molten wax or something, surface will be smooth. But if it is cast in a normal operation where tons and tons of millions of tons are being produced every day, they cannot have smooth finish. For that, to improve their appearance and strength, there are other operations like cold rolling, hot rolling, etc., and those things are all there. After that, again still there will be some sort of rough edges on the metal surface. So, that is removed by grinding operations and then buffing, grinding stone, grinding wheel, milling wheel and scratch rubbing by wire brush or abrasive stone or paper finally. And for finer work, decorative polishing is carried out by polishing with the rough. So, next step involves physical cleaning of the metal part, that is to be electroplated. This involves the removal of oils, greases, polishing material, buffing material and any other dirt and dust and other things attaching to the metal surface during cleaning. So, this is usually accomplished by cleaning it with organic solvents using trichloroethylene or perchloroethylene and ultrasonic application. So, you may be wondering why this trichloroethylene and perchloroethylene. Actually, these two compounds are not very environment friendly. They are implicated in ozone hole formation in the Arctic regions, and somehow they are not favored nowadays internationally, but unfortunately their use keeps on increasing, at least not waning too much. And perchloroethylene, you should know that when you give your clothes for dry cleaning, then people use perchloroethylene. So, that is a very well known application of perchloroethylene for dry cleaning. Similarly, they use trichloroethylene also sometimes. And these two organic compounds are usually not favored, but ultrasonic cleaning that means ultrasonic cleaning is useful, perchloroethylene is useful, trichloroethylene is useful for catching the dust and removing it from strongly adhering metal parts or fabric. So, what we need to do if we have to use these compounds, we have to be extra careful to see that the vapors of these compounds should not escape into the atmosphere, otherwise avoid them altogether. That is a new level of technology that is usually employed, but for the 90% of the time this ultrasonic cleaning is still being used in India. Then it can also be cleaned with alkali, sodium carbonate, sodium hydroxide, sodium silicate, etc., as mixtures or as individual compounds also, with or without electric current, with or without heating also. So, I have not written heating here, but quite often I have not written heating here now. So, but you should understand that higher temperature makes a difference in cleaning. That is why we wash the clothes also in warm water to see that the dirt is blown away. So, the sodium hydroxide, sodium carbonate, sodium silicate are used individually or in mixtures. To remove the surface dirt, simple immersion in aqueous cleaner may not be adequate at all. Just dip and taking it out is not very effective. Better results are obtained by bubbling a gas on the surface of the metal by rendering it as cathode or anode. That also provides very good scrubbing action. That means, we not only do the cleaning, but aid it mechanically by bubbling a gas. We can bubble air itself, does not matter, but required. So, we can also do this rinsing operations. What is rinsing? As I already told you, rinsing has to be done in clean water, correct. So, that clean water is a highly polar compound. It can it is known to dissolve many of the organic and inorganic compounds, and clean water is essential between the various steps in the electroplating sequence, as I have already told you number of times. This is accomplished by dipping the article in the clean running water, or I can even do the spray rinsing. Spray rinsing is very simple. You just take a jet, hand jet, and then spray it on the metal. That also is known as spray rinsing. But after some time, whenever you start doing this rinsing operations, what happens is the water will get will catch all the chemicals and its quality will go down. So, you need to remove the rinsing water and replenish it with more and more good water. So, the water requirement in electroplating industry is enormous, and good water also, and the bad water that is polluted is equally bad in most of the cases. So, that needs to be treated very carefully, and I have included number of lectures on water treatment in this course also. So, we will discuss it further again in the process waste handling operations. So, coming back to this slide, we need to dip it in the clean running water and spray rinsing we can do, and then the article has to be selected specifically for dip rinsing or spray rinsing, depending on the drag out characteristics of the article being plated. Then in chemical cleanliness, coming back to this, I said just now that we use alkali, sodium carbonate, and then sodium silicate, but it can also be done by dipping in 10 to 30% by volume of HCl or H2SO4 after cleaning. That is important, particularly if the parts are to be first plated in acid solutions. you can't take an article which is dipped in alkali and then put it immediately in the acid for electroplating our train. That is not possible. So, whenever you do alkali cleaning, there is again a requirement of acid cleaning because we need to plate, and we plate it with acid. So, what happens? Instead of that, it is better to include one more acid rinse if you want to plate it immediately. So, with what you will clean it up? You can use hydrochloric acid, sulfuric acid, nitric acid, perchloric acid, hydrofluoric acid. So many acids are there. Best among the lot is hydrochloric acid. We know its chemistry, we know what it can do and what it cannot do, and approximately it is a fairly good reactive acid. Not very harsh to the hands like sulfuric acid or nitric acid, but 10 to 30% nitric acid HCl is fairly good enough to clean most of the dirt and other things for chemical cleanliness. H2SO4 also should be approximately 10 to 30%. So, after cleaning, the parts are removed and checked for tarnish again. If the tarnish is gone, then the next step can be just neutralizing and then going ahead with electroplating. So, this is essential to ensure that the electroplating bath is not affected. Subsequent to the acid dip and the rinse following it, neutralization by dipping workpiece in dilute cyanide solution also is employed if we want to detect the if we want to plate with zinc or gold or anything, then cyanide bath dip also is quite essential. So, quite often we employ that. Now, regarding the preparation of aluminum and magnesium require special treatment, as I had already mentioned to you, because of the oxide coating on the metals. The oxide film is first replaced by thin film of zinc immersing in a solution containing a small amount of alkali. A copper plate from a low pH Rochelle salt or pyrophosphate bath usually precedes a plating operation from any other bath in order to prevent aluminum attack on aluminum by pores in thin zinc film. If we want to do zinc thin film, then it is better to take the copper article, dip it in Rochelle bath or pyrophosphate bath before proceeding. So, in that brings us to almost to the end of our discussion on metallic plating. There are many other platings actually. I have already discussed yesterday that gold, titanium, silver and many other elements, indium, many other elements are there. There is no need for us to go into details of the operations, because the volumes are small and very specific. So, coming back to our electroplating technology, non-metallics can be rendered clean, smooth and conducting before subjecting it to electroplating. Synthetic plastics such as vinyl chloride, vinylidene chloride, bakelite, cellulose derivatives, laminated phenolics, all can be polished by methods comparable to those used in the case of metals. Leather, paper, etc., if you want to clean, then they are also used to remove oils, greases, waxes and then rendered non-porous by coating with shellac or lacquer. A conducting surface is produced by depositing continuous coating of copper or zinc by chemical reduction or metal spraying and by sputtering at high voltage. These are all special technologies that can be employed. So, the acid copper sulphate plating bath is generally most suitable for plating on conductive film. Then plating operations used for metals are also applicable for non-metals. Usually it is the same metal baths, but if a different metal plating is required, then copper bath should be used first as a coating, followed by the other metals coatings. So, I will discuss briefly about the electroplating equipment and operating conditions. The electroplating equipment essentially consists of a plating big tank into which anodes are hung from the outside the bars connected to the positive bus bar on the top. It is known as bus bar, a big metal plate, and conducting current from a generator or a rectifier, because we need very low currents. We do not need 5 amps, 10 amps like what we get in our surroundings normally, but very low currents. And workpiece to be placed is hung on racks like as if it is a cathode, or we make a cathode bar on which we place lot of articles to be plated on the cathode. So, multiple electroplating operations are quite possible, and electroplating is one operation where maximum number of automation happens. So, look at the number of articles being produced, especially very small screws and metal plates and bushes and other things. They are done in barrels in thousands and thousands of materials. So, it is important to have automation so that the rejection percentage will become less and chemicals can be used more economically. We will continue our discussion in the next class, and then we will go on to batteries. Thank you very much.